Good day everyone, and welcome to another lesson in our geography lecture series. Complete this proverb. Man fears blank, but blank fears the pyramids. It's one word in both blank spaces. It starts with the letter T and it has 4 letters. What word is that? Man fears blank, but blank fears the pyramids. If you guessed it, the word is time. Man fears time, but time fears the pyramids. So with that, our topic for today is calculating time. There are several pointers you must keep in mind whenever you are calculating time. 1. Time is gained the further east one travels. Therefore, you're going to add. 2. Time is lost the further west one travels. Therefore, you will subtract time. 15 degrees is equal to 1 hour, and 1 degree is equal to 4 minutes. Each and every one of these pointers will be applied in our lesson. So let us look at it from a graphical perspective. Here we have lines numbering from 0 all the way to 90 on both sides of the red line, which is in the middle, that is worth 0 degrees. This line is what we call the prime meridian or the Greenwich meridian. Now, the further east you travel towards the Greenwich meridian or past the Greenwich meridian, the more you gain time. Therefore, you're going to add whenever you're calculating time. The further west you travel towards the Greenwich meridian or away from the Greenwich meridian, you're going to be losing time. So therefore, we will subtract whenever we are calculating our time from that side of the Greenwich meridian. "15 degrees is equal to 1 hour. So between each of those lines you see in the previous diagram, numbered from 0 to 90 on both sides of the Greenwich meridian, you have 15 degrees, and 15 degrees is equal to 1 hour. Between these lines are other lines that are closer to each other, and each of these lines are worth 1 degree. These lines are 4 minutes apart, and therefore it means that 1 degree is equal to 4 minutes. So this is basically a graphical way of showing the 4 pointers I just listed a while ago. One of the things we need to also make clear is that as the Earth rotates from west to east, it rotates 15 degrees each hour, and it also rotates 1 degree every 4 minutes. Now we will calculate time west and east of the Greenwich meridian. When calculating the time between the prime meridian or 0 degrees and another place located west of the prime meridian, the difference in time between both places is subtracted from the time at Greenwich meridian, because time is lost westwards. Let us look at the question seen here. What time will it be at a place located 105 degrees west if it is 5 p.m. at Greenwich? The first thing we're going to do is to calculate the difference in time between 105 degrees west and the Greenwich meridian. Therefore, we're going to divide our longitude 105 degrees by 15 degrees. We divide by 15 degrees because 15 degrees is equal to 1 hour. So whenever we're working out the difference in time, we always divide by 15 degrees. When we divide 105 degrees by 15 degrees, we get approximately 7 hours. So therefore, the difference in time between the Greenwich meridian and a place located 105 degrees west of the Greenwich meridian is approximately 7 hours. We need to now subtract our 7 hours from the time 5 p.m. This will give us a time of 10 a.m. When we're subtracting our time, we're actually going back 7 hours earlier than 5 p.m., which will land us at approximately 10 a.m. But why do we subtract? Remember, 105 degrees west is located west of the Greenwich meridian. When we are calculating the time going west of the Greenwich meridian, we are losing time. Therefore, we must subtract from the time at the Greenwich meridian in order to find out what time it is at a place located 105 degrees west of the Greenwich meridian. So in this case, we subtract our difference in time, which is 7 hours, from the 5 p.m., which is the time at Greenwich. We're going to further justify this. Here we have our point on the Greenwich meridian, or the prime meridian, and our point at 105 degrees west. Because 105 degrees west is west of the Greenwich meridian, or the prime meridian as it also known, we are actually losing time going towards the west, or going towards any place west of the Greenwich meridian. In this case, it is at 105 degrees west. It means that we are losing time. Therefore, in order to calculate the approximate time at that place, we must subtract our 7 hours from the time at Greenwich, which is 5 p.m. And it gives us a time at 10 a.m. at a place located at 105 degrees west. And this is the reason why we subtract our 7 hours from our time at Greenwich, because 105 degrees west is located west of the Greenwich meridian. When calculating the time between the prime meridian and another place located east of the prime meridian, the difference in time between both places is added to the time at the Greenwich meridian, since time is gained eastwards. Let us explore this question. Calculate the time of the place located at 45 degrees east if it is 3 p.m. at a place located 0 degrees. In this case, 0 degrees is referring to the Greenwich meridian, or the prime meridian as it also known. We are going to find out the hours between the place located at 45 degrees east and the Greenwich meridian. We do this by dividing the 45 degrees by 15 degrees, because 15 degrees is equal to 1 hour. So we must divide our longitude, which is 45 degrees east, by 15 degrees in order to find out the difference in time between the place located at 45 degrees east and the Greenwich meridian. This would yield us a time difference of 3 hours. Because 45 degrees east is located east of the Greenwich meridian, it means that we are gaining time as we moved eastwards towards 45 degrees. This means that we must now add our 3 hours to the time at Greenwich, which is 3 p.m. 3 hours added to 3 p.m. will give us a time of 6 p.m. Let us justify this with our diagram. So here we have our point on the Greenwich meridian, and then we have 45 degrees east. 45 degrees east is located east of the Greenwich meridian, and because we are moving in an easterly direction, we are gaining time. This means that we will add our time difference of 3 hours to the 3 p.m. at Greenwich meridian in order to get the time 6 p.m. When the time difference of the two locations yield the hour or hours and a remainder, the remainder is converted into degrees. The degree or degrees is then multiplied by 4, as 1 degree is equal to 4 minutes. As you can see illustrated here by the diagram, 1 degree is equal to 4 minutes. That is the reason why when we do get a remainder, we must convert the remainder into degrees. Then we're going to multiply our degrees by 4, since 1 degree is equal to 4 minutes. For example, 65 degrees divided by 15 degrees is equal to 4 and remainder 5. This is translated to mean 4 hours and 5 degrees. This 5 degree is converted to minutes by multiplying the 5 degrees by 4, since 1 degree is equal to 4 minutes. Hence, 5 degrees is equal to 20 minutes. Let us examine this question. If it is 9 p.m. at Greenwich, what time will it be at a place located 95 degrees west? So first, we are going to work out our time difference between 95 degrees west and the Greenwich meridian. We do this by dividing our 95 degrees, which is our longitude, by 15 degrees. Our 95 degrees west, when divided by 15 degrees, is equal to 6 and remainder 5. 6 hours and 5 degrees. Next, because we are going west of Greenwich, which is 95 degrees west, it means that we are losing time. Therefore, we must subtract our 6 hours from our time 9 o'clock, which is at Greenwich. This will give us 3 hours. Now in bracket next to that, you are going to write 4 times 5, which is the 5 degree. Remember, we multiply our 5 degree by 4 because 1 degree is equal to 4 minutes. When we multiply our 5 degrees by 4, we get a time of 20 minutes. So now 5 degrees is equal to 20 minutes. Because we are subtracting, we are going to now further take away our 20 minutes from our 3 hours, which is technically 3 o'clock. When we go back 20 minutes earlier, our time will be 2:40 p.m. Here's another question. What time will it be at a place located 66 degrees west if it is 2 a.m. at Greenwich? We divide our 66 degrees by 15 degrees, because 15 degrees is equal to 1 hour. We get a time of 4 and remainder 6. In other words, 4 hours and 6 degrees. Because we are west of Greenwich, we are going to take away our 4 hours from the time 2 o'clock. When we go back 4 hours earlier than 2 o'clock, it will be 10 hours, technically 10 o'clock. In bracket, we're going to have 4 times 6, which is equal to 24 minutes. Because we are subtracting our time, we must subtract our 24 minutes from our 10 hours. In other words, we're going back 20 minutes earlier, before 10 o'clock. This will give us a time of 9:36 p.m. Therefore, the time at 66 degrees west, while it is 2 o'clock at Greenwich, is approximately 9:36 p.m. Another question. Calculate the time for a place located 85 degrees east if it is 8 p.m. at Greenwich. Now we're calculating a place east of Greenwich. When we work out the difference in time by dividing our longitude 85 degrees by 15 degrees, our answer will be 5 and remainder 10, which means 5 hours and 10 degrees. Because 85 degrees east is located east of the Greenwich meridian, we are going to add our 5 hours to the time 8 o'clock. Therefore, when we go ahead by 5 hours, we will get a time of 1 o'clock, or 1 hour. In bracket, we are going to multiply our 10 degrees by 4, because remember, 1 degree is equal to 4 minutes. So we are going to convert our 10 degrees into minutes. So when we multiply our 4 by 10, we will get 40 minutes. We will add this 40 minutes to 1 hour. Therefore, our time at 85 degrees east is 1:40 a.m. When calculating the time of a location west of the prime meridian from another place that is also west of the prime meridian, the difference in time between both places is calculated by subtracting the lesser longitude from the greater longitude, then divide the difference by 15 degrees. If it is 2 p.m. at 60 degrees west, what time will it be at a place located 150 degrees west? So we work out our time difference by subtracting 60 degrees from 150 degrees, all over 15. We are left with 90 degrees. 90 degrees is divided by 15 degrees because 15 degrees is equal to 1 hour. This will give us a time difference of 6 hours. Because 150 degrees west is located west of 60 degrees west, we are going to subtract our 6 hours from our 2 o'clock. In other words, we're going back 6 hours earlier before 2 o'clock. This will give us a time of approximately 8 a.m. So therefore, the time at 150 degrees west is approximately 8 a.m. Here on our chart, we have 60 degrees west and 150 degrees west. Because 150 degrees west is west of 60 degrees west, it means that we are losing time as we go westwards. Therefore, we must subtract our time difference from the time at 60 degrees west in order to know what time it is at 150 degrees west. That is the reason we subtract, because 150 degrees west is located west of 60 degrees west. When west of Greenwich, If the place for which the time is being sought has the lesser longitude, this means that that place is located east in relation to the other place that has the greater longitude and for which the time is already known. For example, what is the time of the place located 50 degrees west when the time for a place located 75 degrees west is 10 a.m.? In this case, the logical approach is to add the time to the time difference to obtain the precise time, because 15 degrees west is located east of 75 degrees west. So here on our diagram, we have the time being 10 o'clock at 75 degrees west. And we need to know the time at 15 degrees west, because 15 degrees west is located east of 75 degrees west. We will add our difference in time in order to find out what time it is at 15 degrees west, because 15 degrees west is east of 75 degrees west. Remember, the further east you travel towards the Greenwich Meridian or beyond the Greenwich Meridian, the more time you are gaining. And because you're gaining time, in order to calculate the time at a particular location, going eastwards, you must add Let us now test that theory by examining this question. What time is it at 30 degrees west if it is 9 a.m. at 90 degrees west? We will now calculate our difference in time by subtracting our 30 degrees west, which is the lesser longitude, from the 90 degrees west, which is the greater longitude, all over 15 degrees. We are left with 60 degrees. We divide the 60 degrees by 15 simply because 15 degrees is equal to 1 hour. Therefore, our difference in time between 90 degrees west and 30 degrees west is approximately 4 hours. Now, because we are moving in an easterly direction towards 30 degrees west from 90 degrees west, we are going to add our 4 hours to the time 9 o'clock. When we go ahead by 4 hours or add 4 hours to the 9 o'clock, we get 1 p.m., which is the time at 30 degrees east. So here on our chart, we have 90 degrees west and 30 degrees west. Because we want to know the time at 30 degrees west, 30 degrees west is located east of 90 degrees. We are moving eastwards from 90 degrees to 30 degrees west. And because we're gaining time, in order to find out what time it is at 30 degrees west, we add the time difference to the time that is already stated for 90 degrees west. And that is the reason why we add, because 30 degrees west is located east of 90 degrees west. Remember, the further east you travel, the more time is gained. What is the time at a place located 50 degrees west if it is 7 p.m. at a place located 120 degrees west? We will now subtract our 50 degrees from our 120 degrees. We are left with 70. We divide our 70 degrees by 15 degrees because 15 degrees is equal to 1 hour. Therefore, 4 and remainder 10. In other words, 4 hours and 10 degrees. Because 50 degrees west is located east of 120 degrees west, it means that we're moving in an easterly direction. And if we're moving in an easterly direction, it means that we're simply gaining time. If we're gaining time, it means then that we must add the time difference of 4 hours to the time 7 o'clock, which will give us 11 hours. In brackets, we're converting our 10 degrees, which was our remainder 10, by 4, because 1 degree is equal to 4 minutes. Therefore, we're left with 40 minutes. So now 10 degrees is equal to 40 minutes. We are now going to add our 40 minutes to our 11 hours. When we add 40 minutes to 11 hours, we are left with a time of approximately 11:40 p.m. So let us justify this. On our chart, we have here 120 degrees west and 50 degrees west. Because we want to know what time it is at 50 degrees west, we are moving from 20 degrees west in an easterly direction towards 50 degrees west. If we're moving east from 120 degrees west to 50 degrees west, it means that we are gaining time. Therefore, we will add our difference in time between the 120 degrees west and 50 degrees west to the time that is already stated at 120 degrees west. And this is the reason why we add, because 50 degrees west is located east of 120 degrees west. Remember, the further east you travel, the more you gain time. Therefore, you are going to add. When calculating the time west of the prime meridian, if the location for which the time is being calculated has the greater longitude, it is west of the location with the lesser longitude. Therefore, the difference in hours will be subtracted from the time. Example, if it is 12 p.m. at 45 degrees west, what time will it be at 90 degrees west? 90 degrees west, being the greater longitude, is farther west and is therefore west of 45 degrees west. Because of this, the difference in time between both places will be subtracted from the time, in this case 12 p.m. Here on our diagram we have the time being 12 p.m. at 45 degrees west, with us needing to know what time it is at 90 degrees west. Because 90 degrees west is located west of 45 degrees west, it means that we are losing time as we go in a westerly direction. Therefore, we must subtract from the 12 p.m. the time difference that we have garnered in order to find out exactly what time it is at 90 degrees west. If it is 6 a.m. at a place located 35 degrees west, what time will it be at a place located 145 degrees west? We work out our time difference by simply subtracting the lesser longitude, which is 35 degrees, from the greater longitude, 145 degrees, all over 15 degrees. We are left with 110 degrees over 15 degrees. And we divide that 110 by 15 degrees because 15 degrees is equal to 1 hour. Therefore, our answer will be 7 and remainder 5, which is translated to mean 7 hours and 5 degrees. Because we want to know the time at 145 degrees west, and it is located west of 35 degrees west, it means that we're losing time. And if we're losing time, we need to subtract from our time, which is 6 o'clock. When we subtract our 7 hours from 6 o'clock, which in other words then we go back hours earlier than 6 o'clock, we are left with a time of 11 hours, or simply 11 o'clock. In bracket, we're now going to convert our 5 degrees to minutes by multiplying 5 degrees by 4, because remember, 1 degree is equal to 4 minutes. When we convert our 5 degrees into minutes by multiplying it by 4, we get 20 minutes. Since we're subtracting, we now need to subtract our 20 minutes from our 11 hours. In other words, then, we're going back 20 minutes before 11 o'clock. This will give us a time of 10:40 p.m. So the time at 145 degrees west is approximately 10:40 p.m. So let us justify this. So here we have 35 degrees west and 145 degrees west. Since 145 degrees west is west of 35 degrees west, it means that we are losing time as we move towards 45 degrees west. So if we're losing time, it means that we need to subtract. When calculating the time for places east of the Greenwich meridian, if the place for which the time is to be calculated has a greater longitude compared to the other location for which the time is stated, the difference in time between both places will be added to the time because that place is located east of the place for which the time is stated. Example: what is the time for the place located 90 degrees east if it is 1 a.m. at a place located 30 degrees east? The place located 90 degrees east is east of the place that is located 30 degrees east as the longitude increases eastwards, east of the prime meridian. Therefore, the difference in time between the locations will be added to the time 1 a.m. So here on our diagram, we see that the time at 30 degrees east is 1 a.m. We want to know the time at a place located 90 degrees east. Now, because 90 degrees east is located east of 30 degrees east, it is actually located east of easting 30 degrees east. Therefore, we are gaining time, and if we're gaining time, we need to add the time difference to the 1 a.m., which is at 30 degrees east. Calculate the time of country D located at 85 degrees east if it is 4 p.m. at country C located at 55 degrees east. So first we subtract our 55 from 85 all over 15. This will give us 30 degrees divided by 15 degrees because 15 degrees is equal to 1 hour. We have a time difference of 2 hours between 85 degrees east and 55 degrees east. Because 85 degrees east is east of 55 degrees east, we're going to add our time difference of 2 hours to 4 o'clock. When we add 2 hours to 4 o'clock, we're left with a time at 6 p.m. Therefore, the time at 55 degrees east is approximately 6 p.m. So here we have 55 degrees east and 85 degrees east. Because 85 degrees east is located east of 55 degrees east, we add in order to get the time at 85 degrees east, because the further east you travel, the more time you gain, and the more time you gain, it means therefore we have to add in order to find the time at 85 degrees east from a place located 55 degrees east. If it is 6 a.m. at a place located 35 degrees east, what time will it be at 145 degrees east? So we take away our 35 degrees east from our 145 degrees east all over 15 degrees. We divide 110 by 15 degrees and we're left with 7 remainder 5. When we add our 7 hours to the 6 o'clock, we get a time of 1 hour. In bracket, we multiply our 5 degrees by 4 degrees since we want to convert our 5 degrees into minutes. And remember, 1 degree is equal to 4 minutes. Therefore, we're left with 20 minutes adding to 1 hour. And we have the time 1:20 p.m. So here we have the both places, 35 degrees east and 145 degrees east. And because 145 degrees east is located east of 35 degrees east, it means that we are going to add in order to get our time, since time is gained going eastwards. When calculating the time east of the Greenwich meridian, if the place for which you are seeking the time has a lesser longitude in relation to the other place for which the time is stated, then the place with the lesser longitude is located west of the place with the greater longitude. This means time is being lost and we must subtract to the time difference of both places from the time stated. For example, if it is 8 a.m. at 75 degrees east, what time will it be at 15 degrees east? Here, 15 degrees east is west of 75 degrees east, and therefore the difference in time between both places will be subtracted from the time 8 a.m. Here on our diagram, we have the time at 75 degrees east. We want to know what time it is at 15 degrees east. 15 degrees east is located west of 75 degrees east. Now, because we're moving west from 75 degrees east to 15 degrees east, it means that we are going in a westerly direction and we are losing time. And if we are losing time going westwards towards 15 degrees east from 75 degrees east, it means that we need to subtract from the time already stated at 75 degrees east in order to find out what time it is at 15 degrees east. Alright, let us test that scenario once again. What time will it be at country X, located at 25 degrees east, if it is 8 p.m. at country Y, located at 100 degrees east? 100 minus 25 all over 15 gives us 75 over 15. We divide the 75 by 15 and we get 5 hours. Now, because we're going towards 25 degrees east, which is west of 100 degrees east, we need to subtract our 5 hours from the time 8 o'clock. 5 hours prior to 8 o'clock would have been 3 p.m. Therefore, the time at 25 degrees east is approximately 3 p.m. So here we have our chart showing 25 degrees east, 100 degrees east. Because we're going westwards to 25 degrees east, it means that we would have to subtract in order to find out what time it is at 25 degrees east. So because 25 degrees east is located west of 100 degrees east, it means that we're moving in a westerly direction and we're losing time in the process. Therefore, to know what time it is at 25 degrees east, we need to subtract the time difference from the time already stated at 100 degrees east. So this is the reason why we subtract, because 25 degrees east is located west of 100 degrees east. Remember, the further west you travel, the more time you lose. Therefore, we need to subtract. What is the time at a place located 50 degrees east if it is 7 o'clock at a place located 120 degrees east? When we work out our difference in time, we are left with 4 and remainder 10, which is 4 hours and 10 degrees. Because we're moving westwards from 120 degrees east to 50 degrees east, we need to subtract our 4 hours from the time 7 o'clock, which means we have 3 hours. At the same time in bracket next to that, we're going to multiply our 10 degrees by 4, since we need to convert it into minutes. And remember, 1 degree is equal to 4 minutes. Therefore, we're left with 40 minutes. So because we are subtracting, we need to also subtract our 40 minutes from the 3 hours. 40 minutes subtracted from 3 hours, we are left with a time of 2:20 p.m. So here on our chart, you're probably wondering, why did we subtract? Because we want to know the time at 50 degrees east from the place located at 120 degrees east. 50 degrees east is west of 120 degrees east, even though both sides are east of the Greenwich meridian. But because 50 degrees east is located west of 120 degrees east, it means that we're moving in a westerly direction towards 50 degrees east. And if we're going westwards towards 50 degrees east, it means that we're losing time. And if we're losing time, we need to subtract in order to find out what time it is at the place located 50 degrees east. Now we are going to calculate the time across Greenwich meridian. It means that we're going to calculate the time of one place that is located east of the Greenwich meridian and another place located west of the Greenwich meridian. When calculating the time between one location west of the prime meridian and another place east of the prime meridian, the difference in time between both places is calculated by adding the two longitudes and dividing the product by 15. The difference in time is added to the time stated when the place for which the time is to be obtained is located east of the Greenwich meridian, since time is gained eastwards. So let's see how it goes with this one. If it is 12 noon at 30 degrees west, what time will it be at a location or a place located at 60 degrees east? So to work out our time difference, we are going to add 60 degrees to 30 degrees all over 15. We are left with 90 degrees. 90 degrees divided by 15 gives us 6 hours. Now, because we want to know the time of the place located east of Greenwich, we need to add our 6 hours to the 12 noon, alright, or to the 12 o'clock. This will give us approximately 6 p.m. So here we have our 30 degrees west, and then we have 60 degrees east of Greenwich. We want to know the time at 60 degrees east of Greenwich, so because 60 degrees east is located east of Greenwich, moving eastwards mean that we are gaining time, and that is the reason why we add our time difference in order to find out what time it is at 60 degrees east. What time will it be at a place located 111 degrees east? If it is 5 p.m. at 60 degrees at 66 degrees west. 111 plus 66 all over 15. Again, we're adding because one is east of Greenwich, one is west of Greenwich. And when we add them, we get 177 over 15. And when we divide the 177 by the 15 degrees, we get 11 and remainder 12. In other words, 11 hours and 12 degrees. Because we want to know the time of a place east of Greenwich, we need to add our 11 hours to the 5 o'clock. In other words, then we're going to go 11 hours ahead of 5 o'clock. to see what time it would be at that point. And when we go 11 hours ahead, we find out that we have a time, we have 4 o'clock or 4 hours. We're going to now multiply our 12 degrees by 4 to convert it into minutes. We get 48 minutes, and when we add our 48 minutes to the 4 hours, we're left with a time of 4:48 a.m. So the reason why we add is because 111 degrees east is located east of 66 degrees west, and if we're moving in an easterly direction, it means that we are gaining time. So we need to add, when we're calculating the time of a place located east when calculating the time between one location west of the prime meridian and another place east of the prime meridian, the difference in time between both places is calculated by adding the two longitudes and dividing the product by 15 degrees. The difference in time is subtracted from the time stated when the place for which the time is to be calculated is located west of Greenwich meridian, since the time is lost westwards. If it is 7 a.m. at 10 degrees east, what time will it be at a location at 65 degrees west? (10 degrees plus 65 all over 15 is equal to 75 divided by 15, which gives us 5 hours. 7 o'clock minus 5 hours equals 2 a.m. Therefore, the time is 2 a.m. at a place located west of the Greenwich meridian. So here is our justification. We have 10 degrees east and then we have 65 degrees west. Since we want to know the time at a place located 65 degrees west, we are moving in a westerly direction away from 10 degrees east. Because of this, we are losing time, and if we're losing time, we need to subtract in order to find out what time it is at a place located 65 degrees west. Hence, we subtract. Finally, we need to calculate the time of a country A located at 90 degrees west when it is 3 a.m. at country B located at 20 degrees east. So we add our 90 to the 20 degrees all over 15, and then we divide the product, which is 110 degrees, by 15 degrees. We are left with 7 and remainder 5, which is 7 hours and 5 degrees. Since we are moving in a westerly direction, we will subtract our 7 hours from the time 3 o'clock. We are left with 8 hours, technically 8 o'clock, right? When you go back 7 hours earlier than 3 o'clock. Then you're going to multiply your 5 degrees to convert it into minutes. So you're going to multiply that 5 degrees by 4, which will give us 20 minutes. Since we are subtracting, we need to further subtract the 20 minutes from the 8 hours to find out the precise time, and therefore the time is 7:40 p.m. So we justify this by showing you that 90 degrees west is located west of 20 degrees east, and because we're going westwards, we're losing time, and if we're losing time, therefore the obvious thing to do is to subtract our difference in time from the time already stated. We've gone through all the scenarios that could occur in calculating time, and now it is your turn to see how well you have grasped the concept. Feel free to go over the video in order to fully understand what has been explained and demonstrated, before attempting these questions. These are the answers to the question. Even though you know the answers, go ahead and work them out on your own to see if you get the same answers based on what has been explained and demonstrated to you during the course of this video. Thank you very much for watching this video, and I hope you continue to work at your geography and continue to love it with dynamite. Take care everyone, and have a great day.